Hi everyone. In this video we're going to be looking at two examples of the t-test. In this example it says, suppose that in a recent medical study 76 subjects were placed on a specific diet. After 12 months their sample mean weight loss was X bar equal to 2.2 kilograms with a sample standard deviation of S equal to 6.1 kilograms. Can we conclude that the mean weight loss is greater than 0? So it's important to, again, make sure that you're looking at what each of the numbers represents. So this 76 is the sample size. And then we have the sample mean and the sample standard deviation. And the question is whether or not this sample provides evidence that the mean weight loss is greater than 0. So the null hypothesis is that nothing has changed. There's been no weight loss. So we would say that the mean weight loss equals 0. But the alternative is that the mean weight loss is greater than 0. Because we're talking about means, we're going to run a one-sample t-test, and the command for that is simply t-test. And it's in the same place as all of the other tests. It's under stat and then arrow over to tests. So we go to stat, tests, and then t-test is near the top. So here, just like with a t-interval, we can choose between data and stats. And we're going to choose stats because we're given the mean and the standard deviation. Mu sub 0 is the null hypothesis. So remember that anything sub 0 is the null hypothesis, and this is just asking what the null hypothesis value is. Everything else is taken right out of the problem. We have X bar equal to 2.2, S equal to 6.1, and the sample size equal to 76. And then it's asking for the symbol that we're using. So we're saying, is the true proportion greater than what was given in the null hypothesis? So just remember that the symbol there should match your alternative hypothesis. And we are looking for the test statistic and the p-value. And the test statistic for a t-test is t, because we are using the student t models and not the normal model. So once all the information is entered, you're going to scroll down and hit calculate. And then in our output here, we have that the t-score, the test statistic, is 3.144. So that is more than 3 standard deviations away from the mean when we're looking at the sampling distribution of all samples of size 76. And this is really far, right? That's a really big t-score. So the probability of observing this, the p-value, is 0.0012. So that p-value is right here, and I rounded to 4 decimal places. So this is a really small p-value. Notice that in this problem, they did not give us a significance level. Whenever a significance level is not given, you should automatically use 0.05, the standard level. So we'll say that since the p-value is below 0.05, we reject the null hypothesis and conclude that there is enough evidence to suggest that the mean weight loss is above 0 or greater than 0. So again, when it's below the significance level, then we reject the null hypothesis and conclude that there is enough evidence. So I'm going to introduce vocabulary that is from chapter 16 here, because chapter 16 is really short. It's just going to have a few vocabulary questions, and it just makes a little more sense to talk about these vocabulary questions in terms of this problem here. Oops. So we want to look at the meaning of statistically significant versus practically significant. And a few slides back, I had the term statistically significant, and it said that if the p-value is less than the significance level and we reject the null hypothesis, then our results are considered statistically significant. So it's when our p-value is less than the significance level. So we're saying, when we say that something is statistically significant, we say that a change has occurred. But is the change big enough that we would actually want to act on it? And that's where we talk about practical significance. So we have the mathematical conclusion of what's happening, but is it practical to make a change based on what we found mathematically? So I'm using the same problem here, and we got the p-value to be pretty small so that we know that what we found in that last problem was statistically significant. When we want to decide if something's practically significant, we want to look at the confidence interval. So we've determined that the mean amount of weight loss is above 0, but how far above 0 is the question. So we're going to find a 90% confidence interval to determine this. With a t-test, when you want to find the corresponding interval, we're going to use t-interval. And again, your calculator has already populated this information. So when you go to t-interval, you'll already see that x bar is filled in with 2.2, s is 6.1, and n is 76, and you probably won't have to change the C level because you used 90% last time. Or maybe you will. And you should get an interval of 1.0347 to 3.3653. And so this is saying that we are 90% confident that the true mean weight loss is between 1, I'm just going to leave it as 1 and 3.4 kilograms. So the question is this practically significant? Because, so there's about, 2 pounds per kilogram. I think it's just over 2 pounds. So this is saying that this weight loss program is going to give a mean weight loss of anywhere between 2 pounds and about 7 pounds. Is that enough to act on? So I would say that there's like no ad campaign for a diet that's going to say, you can lose anywhere between 2 and 7 pounds, right? Like, they don't say that. They say, you're going to lose 20 pounds, you're going to lose 30 pounds. So I would say that this is not practically significant because this isn't a significant amount of weight loss. I want you to notice, though, that this idea of practical significance is an opinion. So I'm giving my opinion. Other people might say, hey, 7 pounds, that could be the mean, the true mean, and that's pretty good. So I'm going to say that is practically significant. I would do that diet. But in my opinion, this is not practically significant. Because there is, wow, that was the wrong there. Let's try that again. There is not enough weight loss. But again, especially with this problem, this is definitely my opinion. The assumptions and conditions for a t-test are the same as they were for a 1 proportion z interval. So again, you have those 3 core assumptions and conditions, but because we're talking about means, we talk about the nearly normal condition instead of that success-failure condition. And as long as we have a sample size greater than 30, we've met this condition. But if we have a smaller sample size, we do want to check that we don't have any outliers or extreme skew. So the other way that we can run a t-test is with data. So that's what we are showing in this example. It says airlines often use smaller planes to fly short distances. The number of passenger seats for 10 randomly selected small plane types are shown below. Does the data suggest that the mean number of seats on these smaller planes is different from 80? Test your claim at the 0.05 significance level. So the first question is, we're going to put this data into L1. Which row are we using? And I want you to look at the question, because the question is saying, it's talking about the mean number of seats. So it's the number of seats that is our data. This plane type, you can ignore that. It's just kind of labeling the column headings, right? This right here, this is our sample data that we want to enter into L1. So we would put this into L1. And with a sample size this small, we would typically want to look at that box plot and make sure that we don't have any outliers or skew. I forgot to include that in this video. So I just want to kind of like, I'm not going to be able to play that for you, but you can check that. So let's start off with our hypotheses. Our null hypothesis is that they're not different from 80, that the mean is still just 80. But the alternative hypothesis, we're simply asking, is it different from 80, either greater than 80 or less than 80, which would imply not equal to 80. And then we're going to run the t-test, where the mu sub 0 is going to be that null hypothesis value. And then we're going to use the data that we have. So we're going to use data here. So let's show that in the video. So we're going to stat edit and entering the data into L1. Then go to stat tests, choose t-test, and then make sure you choose data since that's what you're given. Then your mu sub 0 is 80, and it's going to ask for your list, which is, L1. It's always L1. And the frequency, which we're always going to leave at 1. And then we're going to choose the symbol for our alternative hypothesis, which is that mu is not equal to the null hypothesis. And then calculate. We want the test statistic, which in this case is a t-score, and a p-value. So when we hit calculate, we get a test statistic of negative 1.8. So 1.8 standard deviations below the mean, but we have a really small sample size. And remember that when we have a really small sample size, we are more likely to have more natural variation. So even though the t-score is close to 2 standard deviations below the mean, because the sample size is so small, we still get a probability that's pretty high, 0.1045. So 10.45% is our probability. And that's not below our significance level. So we would say that since the p-value is above 0.05, we fail to reject the null hypothesis and conclude that there is not enough evidence to suggest that the mean seat number is different from 80. So typically, when we fail to reject the null hypothesis, we don't go and find a confidence interval. We typically only do that when we reject the null, because when we reject the null, we're saying that a change has occurred, and then we want to look at the confidence interval to see what the new thing, the new proportion population parameter is. But I do want to show you what a confidence interval looks like when you fail to reject the null hypothesis. So the same problem, but we are going to find a 95% confidence interval. Again, just if you're curious, the reason that I'm finding a 95% confidence interval here is because that last test that we did was a two-tailed test with 5%. And so the 5% was equally distributed between the left tail and the right tail, which gave us a central 95%. If you're not interested in that, don't worry, I'll always tell you the confidence level. So when we want to find a confidence interval to this, we're going to use t-interval. We already have the data entered. So again, we're choosing data, and there really shouldn't be anything that you have to change here. Your list is L1, the frequency is 1, and then the C level is 95. And you will get an interval of 48.91 to 83.49. And notice that we have a really large interval, and that's because our sample size is only 10. It's really small. So it's much harder to pin down that true proportion mean. So we would say that we are 95% confident that the true mean number of seats is between 48.91 and 83.49. Notice that 80 is in this interval. So while it's still plausible that we have a different mean number of seats than 80, we could have a mean number of seats of 50. It's in this interval. But our specific sample that we found does not provide evidence that the mean number of seats is different from 80, because 80 is in this interval. So we would say no, 80 is in the interval. And this supports what we found in the test, because we failed to reject to that 80 value. And so that mean number of 80 should be in the interval, since we failed to reject it.